So hello everyone. At this class I am going to start one of the important chapter of mathematics that is called limits. Okay? So ये limits जो chapter है वो objective के लिए objective purpose के लिए बहुत ही ज़्यादा important है. Okay, it is just like straight lines, trigonometry ऐसा जो important chapters में already discuss कर लिया. So it is also one of them. Okay. So what about limits? Limit क्या होता है? Since already we have discussed about the function, we know what is function. So basically वो function related topic ही है, क्योंकि limit में भी function दिया रहता है. function से हम लोगों को वो उसका value find out करना पड़ता है. Okay, so let us take one example. मैं एक example से पहले शुरू करना चाहता हूँ. ये limit के बारे में मैं अभी जो discuss करूँगा थोड़ा सा मैं example दे के explain करूँगा ताकि बाद में डेफिनेशंस आराम से समझ में आ जाए. ठीक है. सो लेट अस टेक वन फंक्शन से f of x is equal to x square minus 1 by x minus 1. One rational function is given, x square minus 1 by x minus 1, because this function is in the form of p of x by q of x. Yes, so it is one rational function. Then if I say that I want to find the value of f of 1, then what will be the value of f of 1? Means at x equal to 1, at x is equal to 1, what will be the value of this function? Look at here. At x is equal to 1, f of 1 is undefined only. If I consider this rational function x square minus 1 by x minus 1, then if you want to find the value of this function at x is equal to 1, then we will get undefined result because it is in the form of 0 by 0, 1 minus 1 by 1 minus 1. So 0 by 0 means it is meaningless only, right? Yes. But the same function, if we factorize the numerator and denominator, x square minus 1 can be written as x minus 1 into x plus 1. And the denominator keep as it is, that is x minus 1, then we can eliminate x minus 1 from numerator and denominator. Then see what will happen. F of x is equal to x plus 1 ही रहेगा. Yes, f of x is equal to x plus 1 only when x is not equal to 1. Yes, f of x is equal to x plus 1 only when x is not equal to 1. Look at here, f of x equal to x square minus 1 by x minus 1 I have considered. But if you want to find the value of f of 1, तो इसका रिजल्ट तो अनडिफाइंड होगा. तो मतलब ये फंक्शन का रिजल्ट डिफाइंड होने के लिए, मतलब डेफिनिट वैल्यू पाने के लिए x का वैल्यू 1 हम लोग पुट नहीं कर सकते हैं. यू कैन पुट एनी वैल्यूज अदर देन 1. Yes, in this function we can put any value other than 1. Now the question is why I have taken this example only. I can take any other example. Generally क्या होता है लिमिट का क्वेश्चन में, ये रेशनल फंक्शन ही थोड़ा ज्यादा गड़बड़ कर देता है. ठीक है. नॉर्मल फंक्शन है तो हम लोग डायरेक्ट डिफाइन कर सकते हैं वैल्यूज. नॉर्मल फंक्शन से बाय यूजिंग द कॉन्सेप्ट ऑफ लिमिट वी कैन डिफाइन द वैल्यू, वी कैन डिटरमाइन द वैल्यू. बट मेन प्रॉब्लम ये रेशनल फंक्शन में ही ज्यादातर होता है. तो इसीलिए मैं एक रेशनल फंक्शन का एग्जांपल लेके ही एक्सप्लेन कर रहा हूं लिमिट के बारे में. ठीक है. सो दिस फंक्शन वी कैन डिटरमाइन द वैल्यू ओनली व्हेन x इज नॉट इक्वल टू 1. ऑलराइट. सो नाउ सी आफ्टर कैंसलेशन of x minus 1, now we get f of x is equal to x plus 1. Yes. Let us consider a value of x just greater than 1. Just greater than 1. Let us consider a value of x just greater than 1. Say x is equal to, I have taken 1.2. Suppose x is equal to 1.2. Then what will be the value of f of x? The value of f of x will be then 1.2 plus 1, which means 2.2. Yes or no? So here we can say that if we take a value of x just greater than 1, then the value of f of x will be slightly more than 2, because 2.2 is slightly more than 2 only. and it can be represented by like this. Look at here, if x approaches 1.2, मतलब x का वैल्यू अगर मैं 1.2 पुट करूंगा तो then f of x approaches 2.2. like this you have to represent in case of limit. ये मैं स्टेप बाय स्टेप आ रहा हूं, अभी तक एग्जैक्ट डेफिनेशन में नहीं आया, मैं एग्जांपल के हिसाब से जा रहा हूं ताकि लास्ट में मैं जब डेफिनेशन दूं वो आराम से क्लियर हो जाए. ठीक है. So after getting f of x is equal to x plus 1, now I have taken x is equal to say 1.2. If I take a value just greater than 1, then the value of f of x will be just greater than 2. It can be represented as if x approaches, ये जो एरो मार्क है इसको approaches बोल सकते हैं. ठीक है. If x approaches to 1.2, that is slightly more than 1, then f of x approaches to 2.2, slightly more than 2. In the same way we can say that if we take x, the value of x just less than 1, if we take the value of x slightly less than 1, say x is equal to, I have taken now 0.9, then what will be the value of f of x? 0.9 plus 1, that is 1.9 only. Yes. तो इसका मतलब है क्या? If we take a value of x slightly less than 1, then the value of f of x will be slightly less than 2. Okay. So it can be represented as if x approaches 0.9, then f of x approaches 1.9, that is slightly less than 2. Okay. अभी तुम लोग पूछ सकते हो कि यहाँ पे 1.9 कैसे हुआ? Because f of x is equal to x plus 1. Already I have taken one example. Based on that function only, we can calculate these values. Without any function, we cannot calculate the value. That is why I have taken one function, जिसमें हम लोग x equal to 1 put नहीं कर सकते है कि नहीं? That's why I have written here only when x is not equal to 1. So x is not equal to 1 means you can put any number more than 1 or less than 1, but not exactly equal to 1. Look at here, if you put exactly equal to 1, then this will be 1 minus 1, 0 divided by 1 minus 1, 0. So 0 by 0 is meaningless, undefined. So that is why in case of rational function, what you have to do, first you have to factorize the numerator and denominator and then cancel out the common factors. After the cancellation, then you can put the values. Alright. So इसीलिए मैं रेशनल फंक्शन का ही एग्जांपल लेके एक्सप्लेन कर रहा हूँ लिमिट्स के बारे में. तो लिमिट्स से क्या है? लिमिट्स में क्या होता है कि we will never get the accurate value, we will get the value either, मतलब नियरेस्ट वैल्यू मिलता है हमेशा. ठीक है. लिमिट में हमेशा नियरेस्ट वैल्यू मिला हम लोग निकल सकते हैं. से दिस इज 1 माइनस इंफिनिटी टू प्लस इंफिनिटी. सपोज अभी यहाँ पे मैं 1 क्यों लिया? बिकॉज 1 के लिए ये अनडिफाइंड हो रहा है, ये फंक्शन 1 के लिए अनडिफाइंड हो रहा है. तो इसके लिए क्या करूंगा मैं? एक बार स्लाइटली मोर देन 1 वैल्यू लिया, एक बार स्लाइटली लेस देन 1 वैल्यू लिया. जब x का वैल्यू स्लाइटली मोर देन 1 लिया, से 1.2, तो f ऑफ x का वैल्यू जो फंक्शन क्वेश्चन में दिया गया है वो फंक्शन का वैल्यू स्लाइटली मोर देन 2 होगा. सिमिलरली इफ वी टेक द वैल्यू लेस देन 1 मीन स्लाइटली लेस देन 1, देन द वैल्यू ऑफ f ऑफ x विल बी स्लाइटली लेस देन 2. ओके. सो ये बात हमेशा याद रखना है कि लिमिट में हमेशा नियरेस्ट वैल्यू लेना पड़ता है. नियरेस्ट वैल्यू, नॉट एग्जैक्ट वैल्यू. इन केस ऑफ रेशनल फंक्शन डोंट टेक द एग्जैक्ट वैल्यू. व्हाटएवर वैल्यू इज गिवन, जैसे यहाँ पे मैं एग्जैक्टली इक्वल टू 1 लिया तो सेटिस्फाई नहीं किया, अनडिफाइंड हो गया. सो इन केस ऑफ लिमिट ऑलवेज यू हैव टू टेक द नियरेस्ट वैल्यू. नियरेस्ट वैल्यू मीन्स इफ द वैल्यू इज हियर गिवन 1, so you just take slightly more than 1 or slightly less than 1, so then only you will get the definite value. All right. So अभी जो मैं definition मतलब example दिया, this example in terms of limit, how can we express? Look at here. If we take the value of x slightly more than 1, then the value of f of x is slightly more than 2. Similarly, if we take the value of x slightly less than 1, then the value of f of x will be slightly less than 2. So this one can be represented in terms of limit like this. Limit LIM. This is the short form of limit. LIM. X approaches a, f of x which is equal to L. Limit x approaches a, f of x is equal to L. What does it mean? That is when x approaches a, then f of x approaches L. That is when x approaches a, f of x approaches L. This one I have written in mathematical form. Limit means the nearest values. Okay, x approaches 1.2, so here a is suppose 1.2, then f of x approaches 2.2, so f of x approaches L, so here L is 2.2. In the same way, if we take x approaches number less than 1, so means here a is 0.9, then the value of f of x is 1.9, which is the value of L only. Okay, so this is the mathematical form of a limit. Limit x tends to a, f of x is equal to L whenever x approaches a, then f of x approaches L. मतलब x का वैल्यू अगर हम लोग a पुट करेंगे तो यहाँ पे, तो f of x का जो रिजल्ट होगा उसको L से डिनोट किया गया है, जो यहाँ पे मैं ऑलरेडी पहले ही लिख दिया. If we take a value of x slightly more than 1, then the value of f of x will be slightly more than 2. Similarly, if we take a value of x slightly less than 1, then the value of f of x will be slightly less than 2. So this, in short or in mathematical form, can be represented by like this. Limit, LIM. This is the short form of limit. लिमिट एग्जैक्टली LIM के नीचे x अप्रोचेस a लिखना है. मतलब हम लोग जो x का वैल्यू पुट करेंगे वो एग्जैक्टली लिमिट के नीचे ही लिखना है, जैसे मैं यहाँ पे लिखा, और लिमिट का साइड में लिखना पड़ेगा f of x. So that is limit x approaches a, f of x is equal to L. L is the overall solution of the given limit. Okay, L is the overall solution of the given limit. जो हम लोग सिंप्लीफाई करके निकालेंगे L का वैल्यू, फंक्शन का वैल्यू, वही होगा overall solution. Let us take one example now. Another example. Now simple example I'm giving because already I have given the definition. Based on this definition, now I want to give one example. Let us take limit x approaches 5 x square plus 5. Find out the value of limit x approaches 5 x square plus 5. How to find the value? Before substituting the value of x here, generally हम लोग क्या करते हैं, जो x का वैल्यू मिला 1.2, जस्ट एग्जांपल जो मैं पहले दिया था, वो 1.2 को यहाँ पे पुट किया, तो 1.2 plus 1 is 2.2 मिला. So whenever you are asked to evaluate such type of a function, then the first step is you have to check whether the function here, which one is the function? X square plus 5. X square plus 5 is f of x only, na? So whenever you are asked to find out the value of such type of a function, first of all you have to check whether after substituting the value of x here, will you get definite value or indefinite value. If we will get indefinite value, then we will follow some rules. वो रूल्स में अभी तक नहीं दिया, वो अभी मैं दूंगा. Okay, but if you get definite value after putting the value of x in this function, if we get definite value, then direct we can put the value, right? So let us take, if I put x equal to 5 here, so 5 square is 25, so 25 plus 5, this is equal to 30. So this 30 is a definite value only. ठीक है, 30 is a definite value. So that means this is the solution of this function. That's it. Look at here. मैं क्या बोला था? L is the overall solution of the given function. So here L is 30 और limit x tends to 5 जो दिया गया है, this 5 is nothing but the value of a. Okay, so before substituting the value, once you have to check whether we'll get definite or indefinite value. ठीक है, रफ में चेक करना है. अगर definite value मिला तो direct we can put the value like this. अगर indefinite result है तो then we have to follow some other results. That one we will discuss later on. Okay. So indefinite result generally ये सब रेशनल फंक्शन में ही आता है, इसीलिए मैं रेशनल फंक्शन का एग्जांपल दे के ही एक्सप्लेन कर रहा हूँ. ठीक है, इंडेफिनिट रिजल्ट जो मैं बार बार बोल रहा हूँ, बार बार जो वर्ड यूज कर रहा हूँ, इंडेफिनिट रिजल्ट, इंडेफिनिट सॉल्यूशन, वो इंडेफिनिट सॉल्यूशन जनरली ऐसा फंक्शन में ही आता है, p of x by q of x which is called rational function. ऑलराइट, लुक एट हियर, पहले ही मैं बता दिया था x इक्वल टू 1 यहाँ पे पुट करने से ही तो इंडेफिनिट होता है, तो इंडेफिनिट होने से क्या करना है वो सब रूल्स में अभी डिस्कस करूंगा. ऑलराइट, सो दिस इज द एग्जांपल ऑफ द लिमिट. लिमिट का जो एग्जांपल है बेसिक एग्जांपल दिया, ठीक है. एंड दिस इज द मैथमेटिकल फॉर्म ऑफ limit. All right, limit x tends to a, f of x is equal to L. A is the point, L is the overall solution. All right, so limit means what? In short अगर बताना चाहते हो तो limit means what? Limit means the nearest values, the nearest values. Okay, so now I'm going to discuss if you get indefinite results, means now I'm going to discuss the working rules for finding the limits. All right, so now I'm going to discuss about the working rules for finding the limits. Okay, working rules for finding the limits, that is limit x tends to a or x approaches a, f of x का वैल्यू कैसे निकाला जाता है. There are few working rules. Okay, so rule number one क्या है कि put x is equal to a. Rule number 1, put x is equal to a in the given function. Function means f of x में, ठीक है. Put x is equal to a in the given function if the function gives a definite value. Okay, once again I am repeating the rule number 1. Put x is equal to a in the given function if the function gives us a definite value. Okay, let us take one example. Say limit x tends to 0 sin x. Sin x is also one kind of a function only, which is called a trigonometric function. So limit x tends to 0 sin x. So क्या बोला गया है rule number 1 में? Put x is equal to a. So here what is a? A is 0. So put x is equal to a in the given function if the function gives us a definite result or definite value. So if I put the value of x here, so the value of sin 0 is 0, which is a definite value. So yes, like this we can put. So this is the solution of this question. ठीक है, ये एग्जाम्पल का सोल्यूशन क्या है? 0 means which it is a definite value only. ठीक है, but if the given function gives indefinite result, sometimes you may get indefinite values also. Okay, ऐसा नहीं है कि हमेशा definite value मिलेगा. तो if the given function gives definite indefinite values or indefinite result, then we have to follow some rules. Okay, now I'm going to discuss rule number 2. Rule number 2. तो rule number 2 क्या है कि listen, if the function is a rational function, if the function is a rational function means any function is in the form of px by qx where qx is not equal to 0. If you know the definition of rational number, then you can easily understand the meaning of rational function also. Any function of the form px by q of x where q of x is not equal to 0. Alright, so if the function is in the form of px by qx, matlab in case of rational function, what you have to do? So in case of rational function, the first step is factorize the numerator and denominator. Just now I have explained one example. I have given one example. जो लिमिट का जब डेफिनेशन दिया था तभी मैं बताया था कि f of x equal to x square minus 1 by x minus 1. That was a rational function only, right? So in case of rational function, what you have to do? You have to factorize the numerator and denominator, then cancel out the common factors, and then you can put the value of x. Alright? So let us take one example. Say limit x tends to 3 or x approaches 3, x square minus 3 by x minus 3. One rational function I have given. और जनरली रेशनल फंक्शन से ही इंडेफिनिट वैल्यू पाने का चांसेस ज्यादा है. ठीक है, जनरली इंडेफिनिट फंक्शन का इंडेफिनिट रिजल्ट कहां से मिलता है? हम लोगों को रेशनल फंक्शन से, बिकॉज यही कभी कभी समथिंग बाय जीरो या फिर 0/0 फॉर्म में आ जाता है. देन व्हाट विल हैपन, व्हाट यू हैव टू डू इन केस ऑफ रेशनल फंक्शन, यू हैव टू factorize the numerator and denominator. So before substituting the value of x, you have to factorize this one, sorry, not 3, this is 9. You have to factorize the numerator and denominator. So numerator, after factorization, it can be written as x minus 3 into x plus 3 divided by x minus 3. So x minus 3 will be cancelled. Cancel out the common factor, and then only you can put the value of f of x. You can put the value of x. So limit x tends to 3. Now here the function is x plus 3. Now if I put the value of x here, we will get 6. And 6 is a definite value only. Okay. So this is the difference. So if you get any indefinite result or solution, then you have to factorize the numerator or denominator. Generally it happens in rational function only. अगर मैं यहाँ पे x के जगह में डायरेक्ट 3 पुट कर दूंगा तो इट विल बी मीनिंगलेस ओनली, अनडिफाइंड रिजल्ट होगा. सो इन दैट केस यू हैव टू फैक्टराइज द न्यूमरेटर एंड डिनोमिनेटर if necessary, and then cancel out the common factors. After the cancellation, put the value of x in the function. So then you will get definite value only. ठीक है, तो ऐसा नहीं बोलूंगा कि लिमिट्स में हमेशा इंडेफिनिट रिजल्ट ही आता है. इंडेफिनिट भी मिल सकता है, डेफिनिट भी हो सकता है. ठीक है. सो दिस इज रूल नंबर 2. मतलब अगर रेशनल फंक्शन होगा तो कैसे सिंप्लीफाई करना. और जनरली इफ यू लुक एट द प्रीवियस ईयर्स पेपर, बोर्ड एग्जाम के बारे में मैं बता रहा हूँ, तो रेशनल फंक्शन का क्वेश्चन ही ज्यादातर आता है. मतलब नॉर्मल फंक्शन भी देता है लेकिन रेशनल फंक्शन ज्यादा देता है, क्योंकि रेशनल फंक्शन में ही ज्यादा इंडेफिनिट वैल्यूज, इंडेफिनिट सॉल्यूशन पाने का चांसेस ज्यादा होता है. ठीक है ना. ओके, तो चलो ये हो गया रूल नंबर 2. नेक्स्ट रूल नंबर 3. रूल नंबर 3 में क्या बोला गया है कि इफ द गिवन फंक्शन f of x contains a Sard, S-U-R-D, if the given function contains a Sard, तो फिर अभी Sard क्या है. मैं तो बोल दिया कि if a given function contains a Sard, then what is Sard? You should know the meaning of Sard. What kind of function? Sard function कैसा होता है? So if the function contains a Sard means, look at here, the function must be in the form of like this: root over a plus x minus root over a minus x divided by root over a plus x plus root over a minus x, or root a plus x minus root a minus x by x, or root a plus x plus root a minus x by x, or root a plus x plus root a minus x divided by root a plus x minus root a minus x. So this kind of function means Sard only. A is any value, a कुछ भी हो सकता है. ठीक है. And x, you know, x means it is a function of x, that is why I am using the letter x only, the alphabet x. Okay. So this kind of functions are called Sard functions. So if a function contains a Sard, look at the form of Sard. Sard function कैसा होता है? ये ऐसा भी हो सकता है, this one or this one or this one. ठीक है. So you can note down these all. If the function contains a Sard, then you have to rationalize the function by taking the conjugate of its Sard. If a function contains a Sard, then you have to rationalize by taking the conjugate of the Sard. Conjugate का मतलब opposite sign लेके. मतलब if look at the first expression, so ये expression में numerator में minus है, denominator में plus है. So if you want to rationalize this function by taking the conjugate of the denominator, then you have to take minus sign, because already plus sign है यहाँ पे. तो conjugate means opposite sign. अगर plus है तो उसका opposite sign लेके rationalize करना है, अगर minus है तो उसका opposite sign लेके rationalize करना पड़ता है. ठीक है. So if the function contains a Sard, just you listen now. I will give all the PDF. I will give the PDFs. ये notes सब कुछ दे दूंगा. Just you listen. If the function contains a Sard, then you have to factorize the, you have to rationalize the function by taking the conjugate of the Sard. Okay, so after rationalization only you can put the value of x in the given function. Okay, after rationalization only you can put the value of x in the given function. So let us take one example now. For rule number 3, okay, I am talking about rule number 3. So let us consider limit x tends to 0, root over 1 plus x minus root 1 minus x divided by x. One function is given, root over 1 plus x minus root over 1 minus x divided by x. So first of all, you look at the function here. Whether the function contains a Sard or not. Sard का मतलब कि root over के अंदर कुछ होना चाहिए. It may be in the form of a plus x or a minus x. But it should be in the under the that is root over side. Okay. So here, yes, of course, this function contains a Sard because look at the numerator. In the numerator, root over term is there. तो मतलब इसमें ये Sard है, ये function में Sard है. तो अगर Sard है तो you have to identify the position of the Sard, whether the Sard is there in the numerator or it is there in the denominator. If it is there in the numerator, then you take the conjugate of the Sard and you rationalize it. Why? Because look at the limit value. Here the limit value is 0. If I put 0 here in the numerator as well as in the denominator, again you will get undefined value. ठीक है ना, ये सब जो मैं rule number 2 और rule number 3 बता रहा हूँ, so 2 and 3 basically for undefined, indefinite values. For indefinite values only we can use these two rules, rule number 2 and rule number 3. Because rule number 1 में पहले ही बता दिया था कि rule number 1 में क्या होता है कि अगर definite value मिलेगा तो direct we can put the value of f of x. But if we get indefinite values, then only we'll follow some rules. And the rules are rule number 2 and this one, which is rule number 3 actually. This is rule number 3, right? So rule number 2 में क्या बताया गया था कि rational function होने से कैसे solve करना पड़ता है, कैसे simplify करना पड़ता है. और rule number 3 में क्या बताया गया? If the function contains a Sard, then first of all you have to rationalize the function by taking the conjugate of the Sard. So देखो 0 put करने से undefined होगा, इसीलिए तो rationalize करना पड़ेगा. So limit x tends to 0. Since the Sard term, the Sard is there in the numerator and here the sign is given minus. So take the conjugate of the Sard, that is root over 1 plus x minus root over 1 minus x by x into under root 1 plus x plus root over 1 minus x divided by under root 1 plus x plus root over 1 minus x. Why we are doing like this? क्यों, क्या जरूरत है? Because to get the definite value. If we put the value of x directly here, we will always get the indefinite result. So for getting the definite value only, we are doing like this. That is, we are rationalizing the function. Okay, rationalization करना पड़ेगा. So limit x tends to 0, a minus b into a plus b, a square minus b square, that is 1 plus x minus of 1 minus x means minus minus plus हो जाएगा, divided by x into under root 1 plus x plus under root 1 minus x. So minus 1 plus 1 will be cancelled, x plus x twice x, x plus x twice x. So we can eliminate x from the numerator and denominator. So limit x tends to 0, it is 2 by under root 1 plus x plus under root 1 minus x. तो ये मिलेगा after simplification or after rationalization. Actually our target is to eliminate x from the denominator, because only because of this denominator we are getting indefinite value. Yes or no? We all know that 0 by 1 is 0. 0 मिल सकता है, 0 is a definite value. Yes or no? But 1 by 0 is always undefined, na? So only because of this denominator we are getting indefinite result. So that is why our target is to eliminate this x from the denominator. So ये x को eliminate करने के लिए ही ये सब steps जरूरत है. ठीक है. So if a function, once again I am repeating rule number 3, if a function contains a sard, sard means रूट ओवर के अंदर जो टर्म होता है वो रूट ओवर टर्म वाला वो फंक्शन को ही सार्ड बोला जाता है. ठीक है. सो इफ ए फंक्शन कंटेन्स ए सार्ड, देन फर्स्ट ऑफ ऑल यू हैव टू rationalize the numerator and denominator by taking the conjugate of the sard, and then you simplify this one. After the simplification, now once you can put the value of x. Now if I put the value of x in the denominator, because in the numerator there is no variable, so you can put in the numerator only 1 plus 0 is 1, 1 minus 0 is also 1, 1 plus 1 is 2, 2 by 2 is equal to 1, which is always a definite value, So these are the rules. These are the working rules for finding the limits. Alright. Especially rule number 2 and 3 ज्यादा याद रखना पड़ेगा. ज्यादा मतलब सब कुछ याद रखना है, लेकिन रूल नंबर 2 and 3 ज्यादा इंपॉर्टेंट है एक्चुअली. ठीक है. So these are the working rules. Now I am going to give a few, that is theorems without proof. जो theorem का proof जरूरत नहीं है, सिर्फ theorem याद रखने से होगा. ठीक है. Some fundamental theorems on limits without proof. Number 1, if f of x and g of x, listen, if f of x and g of x are two functions, then limit x tends to x approaches to a, f of x plus g of x, which is equal to limit x approaches a f of x plus limit x approaches a g of x. This is the first fundamental theorem on limits without proof. Proof are not required. Okay. If limit x tends to a f of x plus g of x, then it can be written as limit x tends to a f of x plus limit x tends to a g of x, where f of x and g of x two different functions. Second one, actually here better if I write plus as well as minus, because plus minus के लिए same rule है. Okay. Second one, limit x tends to a or x approaches a, f of x into g of x. Limit x approaches a, f of x into g of x. This is equal to limit x approaches a, f of x into limit x approaches a, g of x. This is working, that is fundamental theorem number 3. I have written here 2 because already मैं यहाँ पे प्लस माइनस दोनों थ्योरम एक साथ दे दिया, तो ये मतलब 3 होगा. ठीक है. So this is number 3. Number 4, limit x approaches a, c into limit x approaches a, c into f of x, where c is any constant. So this is equal to, we can write c into limit x approaches a, f of x. That means अगर कोई फंक्शन के साथ एक कांस्टेंट मल्टीप्लिकेशन फॉर्म में होगा तो वो कांस्टेंट को हम लोग पहले लिमिट्स के बाहर लिख सकते हैं, उसके बाद फंक्शन का वैल्यू निकाल सकते हैं. ठीक है. बट इफ इट इज इन द मल्टीप्लिकेशन फॉर्म, देन ओनली वी कैन डू लाइक दिस. राइट. नेक्स्ट वन, लिमिट x approaches a, f of x by g of x. This is equal to limit x approaches a, f of x divided by limit x approaches a, g of x, provided limit x approaches a, g of x is not equal to 0. Why? Because if the denominator will be 0, then the complete function will be undefined, complete solution will be undefined. Okay. So these are the four fundamental theorems on limits. ये theorems का proof जरूरत नहीं है. So जो theorems का proof जरूरत है, I will give all these results. Okay. So many are there, many theorems are there, formulas are there. So वो सब मैं धीरे धीरे discuss करूँगा. Since today only I have started this topic limit, this chapter. So first of all you go through the concept. And then the working rules, and after that just once you go through this fundamental theorems, Apart from these 4 theorems, many theorems and formulas are there. We will discuss in the next class, and we will discuss even the numericals also in the next class. Okay, so thank you for today.